Space is often shown as quiet, beautiful, and endless. But the reality is far more hostile. The same laws of physics that make the universe work are the ones that make it deadly to us. Once you understand how space actually behaves, it stops feeling distant and starts feeling personal. Here are the top 10 horrifying facts about space that I bet you didn't know. Number 1. A human exposed to space would lose consciousness in about 10–15 seconds. Without air pressure, oxygen can't enter the bloodstream, starving the brain even though the heart keeps beating. In space, your lungs don't pull in oxygen because there's no pressure pushing air into them. Your blood still flows, but it carries less and less oxygen with every heartbeat. The brain, which uses more oxygen than any other organ, shuts down first. That's why blackout happens so fast, before pain or panic can fully set in. Number 2. Some planets are so hot that it rains liquid metal. Iron turns into vapor, rises into the atmosphere, then cools and falls back down as molten metal rain. This happens because the planet orbits extremely close to its star. Heat breaks metal into gas, just like water vapor on Earth. Strong winds then push the metal clouds around the planet at thousands of kilometers per hour before gravity pulls them back down. It's normal weather physics, just using iron instead of water. Number 3. An unseen force is pulling our entire galaxy toward it. The Great Attractor is a massive gravitational region drawing the Milky Way and thousands of galaxies toward it. We know the Great Attractor exists because galaxies are moving in its direction faster than expansion alone can explain. It lies behind dense cosmic dust, blocking direct observation. Scientists believe it's a massive cluster of galaxies whose gravity is strong enough to influence regions of space hundreds of millions of light years away. Number 4. Black holes can tear stars apart before pulling them in. When a star drifts too close, gravity stretches it into a long stream of glowing gas before the black hole consumes it. This happens because gravity near a black hole changes rapidly over short distances. The side of the star facing the black hole is pulled much harder than the far side, stretching the star apart. This process, called a tidal disruption event, heats the torn material until it glows brightly. Astronomers have observed these events in distant galaxies, confirming that black holes don't simply swallow stars whole. Number 5. There are regions of space where temperatures are almost as cold as physically possible. In these areas, atoms barely move, and normal chemistry nearly stops. These ultra-cold regions exist inside dark molecular clouds far from stars. With almost no heat, atoms move so slowly that reactions happen extremely rarely. Temperatures can drop to just a few degrees above absolute zero, the lowest temperature allowed by physics. In this state, matter behaves strangely, and even light struggles to interact with it, creating some of the coldest known environments in the universe. Number 6. Radiation in space can damage human DNA. Without Earth's atmosphere and magnetic field, high-energy particles break DNA strands. Space radiation moves fast enough to punch through cells, damaging DNA directly. Your body can repair some of this damage, but repeated exposure increases the chance of mistakes during repair. Over time, these errors raise cancer risk. This is one of the biggest obstacles to long-term space travel beyond Earth's protective shield. Number 7. Astronauts age slightly slower than people on Earth because time passes more slowly for them. Moving fast and experiencing weaker gravity both slow time. Astronauts orbit Earth at extreme speeds, and atomic clocks show they return fractions of a second younger. It's not noticeable to humans, but it proves time isn't fixed. It flows differently depending on speed and gravity, just like Einstein predicted. Number 8. Particles from exploding stars pass through your body every day without you noticing. These particles, called cosmic rays, travel near the speed of light. When they reach Earth, most are blocked by the atmosphere, but some create secondary particles that reach the surface. They pass straight through matter because they're so small and energetic, leaving no sensation, just evidence that the universe constantly interacts with us. Number 9. Some stars are so large they would swallow Earth's orbit if placed where the Sun is. As certain stars age, their outer layers expand massively, forming red supergiants. These stars aren't denser, they're inflated. Their outer atmosphere can stretch hundreds of millions of kilometers into space. Earth wouldn't crash or burn instantly. It would simply exist inside the star's outer layers, overwhelmed by heat and radiation. Red supergiants are unstable and lose mass constantly. Their outer layers aren't solid, they're turbulent, boiling plasma held loosely by gravity. If Earth were inside one, it wouldn't be crushed like hitting a wall. Instead, it would slowly be stripped apart as heat, radiation, and stellar winds eroded everything, long before the star eventually collapsed or exploded. Now, before I say number 10, make sure you drop a comment below and let me know what your favorite fact on today's video is, and let me know what you want to see a video on next. Number 10. The universe is expanding faster over time due to an unknown force called dark energy. Dark energy doesn't pull objects, it stretches space itself. As space expands, galaxies move apart without traveling through space in the normal sense. The expansion is speeding up, not slowing down, which shocks scientists. Dark energy makes up most of the universe's total energy, yet we still don't know what it actually is. What makes dark energy disturbing is that its effect grows as the universe expands. The more space there is, the stronger its influence becomes. Over vast timescales, this could push distant galaxies beyond our ability to ever see them again. Entire regions of the universe may already be permanently unreachable, erased from view by accelerating expansion. When you really think about it, none of this is happening in some distant sci-fi future. These forces are active right now, all around us, following the same rules they always have. Space doesn't need to be dramatic or violent to be terrifying. It just exists, indifferent to life, time, and scale. And the more we understand it, the clearer one thing becomes: we're very small, and we're incredibly lucky to be here.